Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem based on the concepts of linear equation with two variables. So as per the problem, Ben's Bikes rents racing bikes for $25 a day and mountain bikes for $30 a day. And yesterday's rental charges were $3,450. That means yesterday this company earned a total of $3,450 from rental charges for these two types of bikes. Now there are three parts to this problem. In part A, we have to find the greatest number of racing bikes that could have been rented. Now the greatest number of racing bikes will be rented if all the bikes that were rented yesterday were racing bikes. That means no mountain bike was rented yesterday. So all of the money, $3,450, came from renting racing bikes. So we can calculate the maximum or the greatest number of racing bikes by dividing the total amount of money earned by the money earned from renting one racing bike, which is $25. So there is a very important concept you need to understand and memorize. And I got 138. So that means 138 racing bikes were rented, and that's the greatest number of racing bikes that could have been rented yesterday. Now in part B, we have to find the greatest number of mountain bikes that could have been rented. So for this, we have to use the same concept that we used in part A for racing bikes. So we'll divide the total amount of money earned by the cost of renting one mountain bike, which is $30. So the idea is that the greatest number of mountain bikes will be rented if no racing bike was rented yesterday. So we'll divide 3450 by 30 and I got 115. So this is the maximum number of mountain bikes that could have been rented yesterday. Now in part C, we have to write an equation for the possible combinations of racing and mountain bikes rented yesterday. Now we are not given an exact value for the number of racing and mountain bikes rented yesterday, so we'll have to use variables for these two values. So we'll start by defining these variables using let statements. So our first let statement will be let x represent the number of racing bikes rented yesterday, and the other variable will be for the number of mountain bikes rented yesterday. So let y represent the number of mountain bikes rented yesterday. Now we have to write an equation for the total amount of money earned. Now we are given that the total amount of money earned yesterday was $3,450. Now if we rent X number of racing bikes, so the total amount of money collected from the racing bikes will be 25x, because 25 is the money earned from renting one racing bike, plus the total amount of money from mountain bikes will be 30y, and the sum of these two values should be equal to $3,450. So that's the equation that can be used to show the possible combinations of racing and mountain bikes rented yesterday. Now we have to graph this equation. So for that, we'll have to draw the grid. Now in this case, the variables are x and y. So x here represents the number of racing bikes and y represents the number of mountain bikes. Now the greatest number of racing bikes that are rented happens when no mountain bikes are rented. So that will be the x-intercept for the graph. And for that, we had a value of 138. So that's the x-intercept for the graph of this straight line. Now the greatest number of mountain bikes that were rented were 115, and that happened when no racing bikes were rented. And that's the y-intercept for this graph. We have 2 points that lie on the graph, and this equation is a linear equation. So that means the graph should be a straight line which can be drawn by joining these 2 points. So this is the graph that represents this equation. Now this graph should not go beyond these 2 points because x and y cannot be negative, because x represents the number of racing bikes rented. We cannot have a negative number rented, and same for y. So we should restrict the graph to the first quadrant. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.